Welcome back, geometry students. We are on lesson 8.2 in our similarity unit on page 228. All right, so we're going to kind of get into proof writing today and do a little bit more with proving triangles are similar and so forth. So the first thing we're going to talk about is angle-angle similarity theorem. So this is a little bit different than what you probably remember from like the congruence theorems that we did in the past. We didn't have any ones that were angle-angle or angle-angle-angle because in order for us to have triangles to be congruent, we could draw triangles with, all the same angles but different sizes, right? And so therefore, that wasn't enough to be able to prove that they're congruent. However, now that we're just kind of proving similarity, there's only, if we can draw two angles, if we can show that there's at least two angles in the triangle that are congruent, which, as you know from the triangle sum theorem, automatically means the other angle has to be congruent. So basically all three angles of the triangle are congruent, then the sides have to be proportionate. And so obviously they could be the different size, right? Which would then result in them not being congruent, but you can be a different size and therefore be proportionate. So let's draw, I'm going to do a couple examples. So I'm just going to kind of draw a couple different triangles. So X, Y, and Z here. I'm going to label this as 21 degrees. This is 99 degrees. I'm going to draw a larger triangle here. RST. And we'll label this as 61 degrees and this is 21 degrees. All right, so this is kind of a common example. So it'll ask, in this particular example, you'll state like, okay, are the triangles similar? So what you need to be able to show, and obviously since angle-angle is the only one that we have so far for similarity, we need to either be able to show by definition that the triangles are similar. So for example, to show all three sets of angles are congruent and all sides are proportionate, which we don't have enough information for that, right? We don't have the sides here to be able to determine if the ratios are the same. Or now that we know this theorem, we can just show that two sets of angles are congruent. So what I did is I used my triangle sum theorem and I figured out that this angle here is 60 degrees. And then I figured out angle S over here was 98 degrees. So what I can conclude is that if I have a 60, a 99, and a 21, and then a 61, a 98, and a 21, that is not enough to be able to show that these triangles are similar. So these are not similar triangles because we were not able to, or at least we don't have enough information to be able to prove if they're similar. All right, another example that I wanted to show you is just kind of basically doing a more specific proof. So let's draw a big right triangle. And then we're gonna draw an altitude, which means that that's gonna come at a right angle. So let me add in some symbols here, add in some letters. And then we're gonna write, this is a right angle and this is a right angle. So we have two, so this is called an altitude, right? From a vertex perpendicular to the opposite side. So what we wanna prove here, so our given is our diagram. And so what we wanna prove here is that we want to prove triangle QPR is similar to triangle QTP. So let's set up our statements and reasons, okay? So we're going to do a two-column proof. All right, so let's start with what we were given. So since we were given a diagram, there wasn't like a specific we're given. What you have to do is pay attention to what was provided in the diagram. So we were told that angle P and angle T are right angles. So that's what I'm going to write down for my given. All right, so our goal here is to be able to prove that these two triangles are similar using angle-angle. And so again, what we're trying to prove is QPR, which is the big triangle here, and then QTP, which is the smaller triangle on this side, are similar. So we got to show that two sets of angles there are similar. So even though we know that P and T are right angles,